Okay, as far as I'm concerned, this session is not meant to be a lecture. You're here to hear something about this. We've got far more than we can tell you in an hour and a half. So this talk is about setting a bit of a background, but if there are other things you want to know about, please, when we come to the question and answer session at the end, please ask. So when José Luis set this session up, we looked at this and said, we are very close to the end of the project now, and a lot of the things that we set out to do, we think we are demonstrating and showing. And the important bit of this project is that we are demonstrating to the European Commission, and we are trying to demonstrate to manufacturers, professional bodies, all of whom are involved in the project, whether or not this is a sensible way of us controlling energy use across buildings in Europe. So I am going to go back through a little bit of the history of why we have arrived at where we are now, and hopefully so that you can see the likelihood of this being enacted and whether or not you should react to it, both at a legislative point of view and just from does it make sense from an energy and a cost point of view. So I try and keep it simple. I know you will all have different questions that maybe you want to answer from this. So we will stop this after about 14 slides, so there'll be an opportunity to ask questions about the policy part, and then I will go on to the second part to talk about actually iSERV and what we have found and what we would like to tell you about. Okay. So what we're interested in, all of us can collect data. It's a very common thing now. Everybody can get data out of systems and sensors and everything else, and it sort of looks like this, and people look at it and say, I'm collecting energy data, I'm now managing my energy. I have no idea what that would mean in terms of an action. What do you do? If you have something like that, what does it mean? How do you persuade somebody to give you money? How do you decide there is something good or bad about that? So what we are trying to do is to say, let's give some benchmarks to this. Let's describe the building, all the activities, the HVAC components, connect that to the metering, connect all your components to each other and to the spaces they serve to come up with ranges of benchmarks which we think accurately describe what that building ought to do. So this is the same data as on the previous page, but the traffic light system behind is derived from each area of the building in square meters, plus the activity that takes place in each of those areas, so whether it's a restaurant or an office or a corridor or a laboratory, along with what are the HVAC, the heating, ventilation and air conditioning components that are serving those areas, and the metering that goes into the components. So we know what the components are consuming, we know what they're attached to, and we have ranges of real energy use that are happening in real buildings that cover the operation of those bits of system serving those activities. So it's quite complex and it requires a bit of detail, but the whole world is moving towards building information modeling. We are starting to understand our building this level of detail. It makes no sense for us still to deliver or deal with energy use of buildings at the level of the overall energy use of my building is so much through the main meter. We can't make decisions on reducing it, we just know what we've got. So we're going from the other end to try and give you information on which you can make a decision. So we can give that last one was for the building as a whole. We can also give you benchmarks for an individual component or for a system which is an assemblage of HVAC components. This particular graph shows that the blue lines here, we have measured this, but from our benchmarks we're also able to estimate what the energy use is likely to be in this particular system based on all its components. Even though we're not measuring it, we can think, okay, your consumption is likely to be in this range based on other energy use we know that is happening in that type of component in another building somewhere. So I'm just trying to give you some idea of what we're trying to aim for before I go into the basis of why we need to do this at all. So, from information to action, how do we, we've been talking about reducing energy use in buildings for a long time. The legislation, as legislation always does, starts off easy. Nobody wants to do this at all. Let's put something in that we can all sort of agree, yeah, we don't have to do too much, but we've agreed we need to save energy, so we start off easy, and then it gradually becomes more difficult to achieve. So, the very first EPBD, which was December 2002, set out a series of rules about the energy performance of buildings. And the initial thoughts were, in order to control energy use in buildings, we should have inspections, and we should have display energy certificates which attempt to rank how well a building is performing. So back in 2005-2006, a lot of the members who are in the iSERV consortium were part of a project run out of Paris, in École de Mines, which was a European Commission-funded project called Auditac. And that was meant to say, okay, the Energy Performance of Buildings Directive now requires inspections. We will do a 2-year project to see how much energy inspections save. We spent 2 years realizing that nobody knew anything about energy use in air conditioning systems at all. The information that we assumed existed out in public didn't exist in reality. And so at the end of 2 years, the conclusions were there are too many systems to inspect, not enough inspectors, and nobody knows how much energy inspection is meant to save. Okay. As a result of that, the European Commission requested the people who are in the Auditac project to propose another project to find out and actually measure how much energy inspections were saving by comparing it to buildings when we actually monitored those systems. So that project was a project called Harmonac, and that took us 3 years, and coming out of that is the reason that this project we're about to talk to now, which is iSERV, came about. So let me take you through a little bit of that. Firstly, just a very simple theory. So none of this is rocket science. All of you here will know this. To save energy, it's very easy in buildings. You can design it out. So you can design your buildings or your services or systems so that you don't need to put energy into it. So we're sat in a room which, as best as I can figure out, has no air conditioning in it, and I'm boiling to death, but it's energy efficient. So there's, we're starting already to look at different ways that people might want to condition spaces. And ironically, in 8 years of doing this, I have been uncomfortable in 8 years of looking at energy efficiency in buildings in most spaces I've been in. But we are trying to figure out what is reasonable to consume in these systems to make a space appropriate for the activity that you want to put in it. So we can design its use out. The way you design the building, the materials, how tall the space is, these are all ways that we can sort of try to avoid the use in the first place. But when we have decided we need to put systems in and we've still got ventilation into the space, then how efficient can we make the equipment to serve that? So we have Eurovent certification for whom a lot of manufacturers will put their equipment to say, I have an air handling unit or a chiller, and if it's doing this duty, you can expect to use so much energy. So we are trying to get more efficient equipment, and legislation is moving towards that. And the last thing we can do is we can control it better. You can put the most efficient equipment on, but if it runs all the time when it's not needed, it uses more energy than it needs to. So none of that's difficult. I apologise for how dense this is, but the slides will come to you afterwards in case any of these you wish to look at again. Until relatively recently, building fabric, so the way we designed the outside skin of the building, we didn't pay much attention to it. It had been done the same way for thousands of years. And then we started looking at heavily insulating buildings, low energy buildings, over-insulating them. And for newer buildings, having taken out a lot of the fabric demands on your HVAC system, the new design of HVAC systems is not relating anymore to the way it's traditionally been done. For years you always did the same thing and you knew the system would sort of work. Now that we've got rid of a lot of the fabric load, which was a big proportion, the loads that are now on our HVAC systems are much more variable. So we have people coming in and out of rooms. The sun shines or it doesn't shine. In the UK, mostly doesn't shine. And we also have how much ventilation do we need. But because the fabric is now not a big component, the loads and the way our HVAC systems need to act change quite quickly. So the overall effect on designing HVAC systems when we're trying to get low energy systems are the demands are much less predictable, and it has become more difficult to be a HVAC engineer and to produce low energy systems. So we need to try and find some way of designing systems which will act as low energy in practice, that we can put into practice knowing we're likely to be correct. Why is this important? Because we know already that a lot of contracts for new buildings are moving towards performance-based contracts. So if you are designing for new buildings, the end users are expecting a lot of people now, certainly on the bigger buildings, to sign up to performance contracts. So you will guarantee that you will provide a certain energy efficiency in what you're doing. How do you do that if nobody knows? So we have all these demands coming in, and yet we don't know a lot of the answers. So what can we do about saving energy in systems? What is possible? So there are studies that most of us who are in these projects have been involved in one way or the other, and these studies have shown there are significant potential for saving energy in HVAC systems through load reduction, so that's the reducing the demand we talked about, improved efficiency and the better operation. And this graph here shows coming out of the Harmonac project, which is the project preceding iSERV. When we looked at where the energy was going and what the potential for savings were, we could see that we could reduce energy use by about 24% by making better fabric improvements than already existed. The more efficient plant accounted for nearly 40% of the energy reductions we could make, and the other 37% was to do with operating and maintaining the systems better. Okay, that's sort of, okay, that all makes sense. But in practice, when we're trying to do this practically, we have some constraints. So for real buildings, where people are spending money and trying to design or make things, the constraints which reduce the speed with which we can make buildings energy efficient are replacement rates. If you just put a system in, chances are you won't replace it for another 15, 20 years, maybe longer. So once a system is in, it's very difficult to achieve those savings again. So we restrict what we can achieve. How often we need to renovate the building. So many modern commercial buildings might be turned over every 7 to 10 years, and you may have fairly rapid renovation, but most buildings, again, it's quite a long time between opportunities. And the last one, cost and ambition level. You know, if it's too expensive, it doesn't matter what it might save, somebody's got to pay for it, and who will pay for this? So the policy instruments. So the European Commission, the European Union, member states are all anxious to reduce the energy use in our buildings for two reasons, one of which is to make us more competitive on a global scale, but also because the energy supplies into Europe are less certain than they used to be. So we have two reasons for doing this. So it's important, which is why we have a lot of policy documents. So for load reduction, we have building energy standards, office equipment, lighting energy standards to try and help reduce the loads actually on the system. For efficiency, we have system and product efficiency standards. And for operation, at the moment, we have the mandatory system inspections, which are, the best way of describing those, are not necessarily a superb success across Europe. Portuguese seem to be slightly better at it than every other place except Germany, who are very good at it. Everybody else seems not to care a great deal about inspections. And benchmarks and consumption analysis. So we are trying to give you display energy certificates to suggest how well a building might be performing. So the thing that we really have access to when our buildings are operational and when we're trying to make improvements are the operation and maintenance, or O&M savings. Those are the ones where we can really make some savings if we look at those, because everything else, the design of the building, the systems, those are open to us far less often. So we're looking at operation and maintenance. Those are the ones we really want to look at, because they're where the big savings are to be made. And I will show you in iSERV just how big those savings can be. What is potentially achievable? So this is there was a study which was funded by an organisation called CLASP. I'm sorry, I can't tell you what that stands for. But they did a modelling study across all the European member states, all 27, plus Norway, Iceland and Liechtenstein. And it modelled, it took averages and made assumptions based on studies of installed equipment and normal sort of end sector end uses, to come up with a series of slides on where would we best put our time and effort from a policy point of view in trying to achieve these energy reductions. So, assuming that we were looking for a 30% reduction in our normal base case, so that's where we are at this moment in time, over a 10-year period, and these are savings in terawatt hours of electricity, these are the things that they said would achieve the most effective means of reducing energy use in buildings. So, minimum performance requirements for chillers, room air conditioners and other packaged units. So the cooling side of things, there's the third largest potential came from that. Performance requirements for specific fan power and air leakage. Okay, less than you might have expected, because air conditioning, air handling is a big energy consumer, but SFPs and air leakage don't seem to give that big a saving. Minimum energy performance requirements for complete systems. So this isn't components, this is when they're assembled, can we set up how those components should go together, and again, a relatively significant saving. Minimum performance requirements where we integrate buildings and systems. So no longer do you look at a component, I put in a very efficient pump in, but hey, I don't care what it connects to. We're saying, okay, you need to look at everything as a whole, so it's all integrated. That gives the biggest potential savings. And we're likely to, well, we know that's coming in already, because building information modelling allows us to do that now. Whether the modelling is accurate is different, but we now have all the information to do these things. Reduce fresh air in spaces where smoking is now prohibited. Well, yes, okay, if you take it down to a quarter of what it was before, there's lots of savings to be made. And probably most of those are already made where smoking is actually prohibited as opposed to theoretically prohibited. And detailed audits of air conditioning systems. So again, this is big. If we can get people to go in and look at these systems when they're operating, there are big savings to be made. So, of those things that we've identified as important, what's the legislation that is requiring us to do this? Well, the new Eco-Design Directive is looking at system efficiency. We have national codes which come under as a result of the EPBD for specific fan power, minimum energy performance requirements, and minimum performance requirements integrating buildings and systems. The operational practice, this thing that we really have access to, not really. The only things we've got for that are inspection and display energy certificates, which are indirect. They don't tell us to do something, they just tell us the results of not doing something or what we're currently doing. So don't tell us how to achieve it, it just tell us what's going on. And again, reduce fresh air, national design codes and audits. So despite the importance of this operational side of things, it's clear that it's not yet well addressed by European legislation. The Commission know this. They know it's a problem, and it's the reason they sponsored Harmonac, and it's the reason they have asked us to do iSERV and have paid for iSERV to be done. They want this information, and we are busy trying to assemble it for them. So, the European air conditioning market. After, from 2002, when we started talking about energy performance of buildings, the market for air conditioning is growing exponentially. So nothing's gone down, in fact it's going the other way. Now there are two probable reasons for this, one of which is in new build, the increased fabric insulation standards, which have been very successfully driven by the insulation manufacturers, now require all buildings to be heavily insulated. Unsurprisingly, we see a massive growth in air conditioning to cool them down because we can't get the heat out of our buildings. So that's driving it in the new build, and for existing buildings there is an expectation in a lot of places that we should have air conditioning to be more comfortable. So we've got two things going on, one of which is some of the legislation which has been single issue. We can make buildings low energy and more efficient by just insulating them to death. Well, unsurprisingly, we've reached a point where maybe there's too much insulation in some of our buildings, and we could look at doing this smarter rather than just trying to have single issues to say, okay, do this and you will be energy efficient. We know for the low or zero energy buildings we're aiming for, we cannot do that. Okay? You cannot design low or zero energy buildings without knowing what you are going to put in the building and the internal gains that those activities are going to put into your space. So, coming to the last thing now, so this is the last part of just looking at the policy and why we've ended up to where we are now before I go into iSERV. The rest of this presentation, after this short break, will look at actually what we're finding when we've been doing it and measuring systems in buildings. So is there any questions at this point? Or?
This is our first part of presentation about the context in terms of energy in Europe. Then now we continue if there are no questions. If there are questions, please. Okay, we continue the presentation with explain what is the iSERV project, how is the meaning of this project in this context that we talk about. Okay, go ahead, it's your turn. Yeah.
Okay, I'm the only person you get to hear from before coffee. I apologise, and if I'm speaking too quickly as well, please somebody put your hand up and say you have a funny accent and you speak too quickly. So if you don't understand me, please somebody tell me to slow down. So, what is the iSERV project? Wall of text. This is more for me than it is for you, but as I've said already, we set out in Harmonac to discover actually how well an inspection would do if against really well monitored systems. So we went in 42 case studies from around European member states, so different ways of running buildings, different operations, different practices. We put monitoring into all the systems to try and understand them in some detail, and then we sent people in to do inspections in them and see what the inspectors found compared to what the monitoring was telling us. From this, we also wanted to assemble a list of what we call ECOs, or energy conservation opportunities. When we look at these, how many ways could we practically reduce energy use in air conditioning systems? And we identified about 142 different ways of reducing energy use in operational air conditioning systems, all of which are described in the Harmonac project website, the website name of which I gave you before, so you can still download that report if you're interested in looking at those. What we concluded was that inspection, done by competent inspectors, these are people who actually cared, that for those who don't care, they'll probably identify far less. On average, only 37% of what the monitoring was telling us was available to reduce did the inspector find. That's not because the inspector's incompetent, it's because a one-off snapshot in time didn't tell you about the fact that the system was running badly at weekends, or it wasn't, or during the summer it was left on when there was nobody there. So lots of opportunities which are time-based and not just to do with immediate equipment or operational at the time of the inspection. The other reason that inspections are problematic, and the European Commission knows this, is that there is no way of assessing whether an inspection is achieving anything. So you go in, you have no monitoring beforehand, you have no monitoring afterwards. So you've paid for an inspection, what happened? Have you saved anything? Has anybody benefited? So other than introducing a cost, where is the benefit of introducing that cost against business? Where is the benefit to the organisation, the country and the EU? All the legislators are very unhappy in all the countries except one or two with inspection because the owners don't understand it, they don't understand the benefits, and nobody can show the benefits. They may well be achieving benefits, but it is not possible to show. And as we have technocrats and people who like to measure things, if you can't measure it, it doesn't exist. So unfortunately, that's how most legislation works. So we can't see it, can't measure it, therefore it rapidly loses any credibility. So the only thing people are seeing is the cost, and so they wanted to change that. So what came out of Harmonac? So as a result of Harmonac, in 2010, the final report from Harmonac came out, and in the following years, the recast EPBD came out, and as a result of Harmonac, they changed the rules for inspection and for air conditioning and heating systems. They now allow automatic monitoring and feedback as an alternative to inspection, but they also allow advice, so you don't need to do anything now. Okay? So from the recast EPBD, member states have the option of not doing inspections anymore and just giving advice to people on how to make their systems more efficient. That is because the inspection process was so unpopular that they demanded the Commission give them an alternative. So what the Commission want is automatic monitoring and feedback. What the member states were prepared to accept at that time, because nobody could prove automatic monitoring and feedback, which is another cost, actually achieved anything, they also insisted advice were available. So we now have 3 ways of dealing with these systems: advice, inspection, automatic monitoring and feedback. So what you should read into that is that basically there's an acknowledgement that inspections were probably not the right way forward, and in the future I'd imagine the Commission are going to try and move away, and the Member States will try and move away from inspection, unless iSERV or other things like that show that actually there's some really good savings to be made. So, why no Member States yet propose to legislate for automatic monitoring and feedback? So as I've said before, there's insufficient evidence. We know these things should work. Harmonac has showed really good savings, but it's a small study, 42 case studies. You're hardly going to set up $1 billion or €1 billion industry on the basis of a very small study on 42 systems. So they want more evidence, which is what iSERV is doing. And from a legislator's point of view, no matter how poor inspection is, it still meets the requirements that Europe are asking. So they've gone to the effort of setting up an inspection scheme. Okay, we keep going with it. I don't have to do any work. That's fine. For me as a legislator, I've done my bit. I've enacted the legislation. I don't want to change it unless I have to. So, you could say, okay, we're going to end up with advice or remain with inspection. The Commission, however, does not want that to happen. So whatever it says, it isn't achieving its targets of reducing energy use. In fact, energy use in buildings is continuing to go up, and then no way are we going to meet our targets for 2020. So the Commission requires that to change from inspection, you must show that advice or automatic monitoring and feedback achieve at least the same impact as the inspection is doing. Now, advice has the same problem as inspection. You can't prove it's doing anything because nobody's measuring anything. So the only thing that you can prove as a member state is the automatic monitoring and feedback, and you can show that that is at least as good as inspection because Harmonac and now iSERV will prove it. So you can refer to evidence to show it will. From Harmonac, we are able to show that in monitoring and targeting or monitoring and feedback gives much better savings than inspection. So all of that sets the scene for iSERV or iSERVcmb. We can't use iSERV because somebody's already got a trade name on that, so we have to put the CMB on there. It's a horrible name, I know. It's as close as I could get to something when I was thinking of an acronym for the project. So, iSERV, it's the largest project ever funded through the Intelligent Energy Europe programme by the Commission because they consider it that important. So what we're about to tell you here today, we're only 8 months away from the end. We're starting to understand what we're likely to see. Okay, and these are the sorts of things that are going to go back to the Commission, and these will be the things that they start to react to. In a month's time, I go to Sweden to present this to the European Member States legislators as they're looking to transpose the recast EPBD into national legislation as well. So I will be trying to persuade them that they should allow an option for monitoring and feedback based on what we're finding. Whether or not any member states do or not, we don't know. So that's political, this is technical. So the purpose of the project, lots of things come out of this. We've got so much data, we've got so many things we could tell you, I don't know where to start, so it's a bit of a problem. But what we have to do is establish the impact of monitoring and feedback on energy consumption of real systems. So what happened when we gave the feedback, what savings were achieved. We have to establish benchmarks against which we can set up those traffic light systems for each system and building that we showed you earlier. We have to establish a process and procedure as to how such a scheme might operate, so member states and legislators can refer to it or understand how they might turn that into legislation. And we have to help the Commission and the legislators frame future legislation in this area. So, what have we achieved? After 27 months of the 36-month project, this finishes May next year, we have a procedure for describing buildings, activities and all the components in our HVAC systems that can be used to underpin this type of procedure. We have recruited at the moment over 1,000 HVAC systems across Europe and the accompanying sub-hourly consumption data for all parts of those systems. So we're getting lots of data, we've got lots of systems stacked around various parts of Europe. We have set up an online database to collect, analyse and report performance. That database is the bit that we're sort of working with at the moment, because before we give things back outside of the project, we have to make sure we're not giving feedback to people that we're going to change pretty rapidly. Because we're the best will in the world, the moment anything comes out of the project to the end users, they're not going to question it. So before we give anything back, we have to make sure it's right. So it's taken a little longer than we hoped, but we are nearly there. We have measured electrical consumption savings from buildings which took part in the Harmonac project, and over time we've been able to show the savings that have been achieved, and those have been quite spectacular and unexpected, and I'll talk to you about why. One of the other things, of course, that's an issue to everybody is say, okay, it's easy to save energy, just turn the air conditioning off, turn the ventilation off. That's energy efficient. So to get past that argument that we might be setting the benchmarks in the wrong area, we also do indoor air quality studies, which we have experts on the project to do that, and we are doing physical inspections of systems, and we have sort of commercial companies doing that, and indeed they're off doing inspections of parts of the university campus at this moment in time. So you've got some problems in part of Europe. Where was the problem? Yeah, so some of the kit in this building you may not want to go too close to. Right. And finally, we are producing algorithms and models. So we're collecting all this data. By looking at the data, there are patterns and things which are to do with how we expect the building to be used and actually what the data is telling us. So we've got algorithms which will automatically take that data, look at it and say, it appears that you could save X amount of energy because this is happening or by doing this action. So we're trying to automate some of that feedback. So rather than you just collecting data, which across the whole of Europe, people have got BMSs everywhere, they've got data overload, it means nothing. In my university, we have 220 buildings. The BMS operator, he will get about 600 alarms coming every day, and he says, ignore. Okay? Critical alarms, things have gone down, stuff is broken, ignore. Because too many alarms, can't do anything with it. So data on its own is pointless. You have to do something with that data and have something that data is going to give you an action to do. So data collection is not energy management. Data collection and analysis against a target, then you can manage. Okay, so now I'll take you on to the savings we're achieving. I apologise, they're all UK. That happens to be where I'm from, and I know these buildings. I am satisfied that what I'm about to tell you is correct, and I know why they've been achieved. Wall of numbers. I've tried to make the important numbers bigger, because what I want to show you is this straight commercially makes sense. Okay? Ignore legislation, ignore everything else. This is an 8-storey massive headquarter office block for an international company in the centre of London. It's got loads of things in it you wouldn't put in a building if you wanted it to be energy efficient. A couple of restaurants, gyms, IT suites. I'm not sure if they actually do any work in there, but it's meant to be an office building. During Harmonac, we went through with them and we clarified where their systems were serving. They didn't know. They were controlling systems, they didn't know where the system served, they didn't know what they were meant to do, no idea what was set up. It was, the building systems were 20 years old, everybody left, so the control was basically, we turn it on and we leave it on. So, as a result of doing the original savings, they've done a massive investment, and I'll show you the graph of the energy reduction in the whole building on the next slide. But the total building electricity consumption is about 19% before they've done the refurbishment. So this is the whole electricity use of the building, not just the HVAC system, but the whole building. It took us about 50 man days. Okay, we did it for free, it's through the project, but if at a consultancy rate of between 500 to 1,000 euros a day, which is very generous, so we're conservative, it would cost you about 25 to 50,000 euros to describe this building in a manner that would allow it to participate in iSERV. That's about 1 to 2 euros per square metre to set the building up. One-off cost, once it's done, you're only tweaking it on an annual basis. The savings, we've got 2,000 megawatt hours or 80 kilowatt hours per square metre per annum saving at the moment before the refurbishment. That's saving us 7.5 euros per square metre per year. So very quickly, you can see that even though you're investing 25 to 50k, were they to pay for it commercially, they're getting that paid back in less than a quarter of a year. Then, you've only got that expense once. For the rest of the time, we're probably looking at around 3 euros a square metre per annum to maintain, keep the meters running, somebody to employ it, collect the data, and pay somebody to analyse the data. We're still, in that building, saving just over 6 euros per square metre per year. So it makes sense from a straight cost point of view. They've done little or nothing to achieve the vast majority of the original savings. Just know what you're controlling, change the controls. Operation and maintenance, very simple. The other two buildings, so this building, you can see it's crap. It's using about 430 kilowatt hours per square metre per annum of electricity. That's, we have a power station just for this building. So the reduction even down to here, and this is where they spent a year refurbishing it, so we're expecting that to come back a little bit more before the full year's rolling growth is back in. I reckon they've still got another 150 kilowatt hours per square metre they can save in this building. So they just but they know now where to save it. We've given them the tools to do this. We only expected about 5 or 6% reduction in the total energy use of the building from the HVAC system. What was unexpected was because they saved that money in the HVAC system, they suddenly had it to spend elsewhere. The finance director suddenly trusted them. Oh, you've saved that. You told me you'd save it. You've saved it. Yeah, have some more money, save me some more. So they went away and then did lighting and other things which are nothing to do with HVAC, but you've released the capital and you've released the confidence to go ahead and get those. Okay, so the next one, this is the other end of the scale. It's another office building. The last one is 26,000 square metres. This is 220. It's 2-storey, tiny. Almost exactly the same level of savings. We've got 33% saving reduction here. Took us half a day to describe it. It's a small building. The system is very simple. Again, though, the budget worked out between 1 or 2 euros per square metre to do it. What they did, as a result of doing it, they replaced the old multi-split system in there with a new one. They've achieved 91 kilowatt hours per square metre per annum savings from doing that. I've tried to get the cost, so despite him being a member of the thing, I didn't ask him early enough. Sorry, Dave. I take it you still haven't got it. And those savings are around 14 euros per square metre. So we're in the same sort of ballpark. Again, similar sort of costs of maintaining it, because less meters, less costs involved. And again, slightly higher savings per square metre. This is the description of the building within iSERV. We don't have the main incomer data for this building, but we can still produce the range of consumptions we expect the building as a whole to do. I've put this figure in here because I went through the bills and just said, okay, I'll just overlay what's actually being used. So this building, against benchmarks for what it's actually doing inside it, is about average. So there's further savings to be made there based on what we think the benchmark should be. Because of the sub-metering, we can see that almost all the energy in the ventilation system, in the air conditioning and heating system, is in the outdoor unit. So we thought maybe the fan coil units might be running and taking up a lot of energy, but really it's next to nothing. The third one, this is intermediate. It's again office, but it's about 8,500 square metres, not particularly prestigious, so it's my university administration building. And again, 33% reduction. And so we're seeing the same savings all the time. The moment you give people the ability to understand their building and their systems, they can go away and make very significant savings. And again, cutting to the chase, cost savings somewhere between sort of the 6 and 8 that we've seen before. So overall, and that's how that building is performing. So it's gone from average over the 5 years since we started, and it's just above the good band now, and we reckon it'll get into good once they've replaced a couple of the bits of equipment they're looking at. So all of these things, net returns, after all costs and setups, it makes sense to do. But also, those savings are far greater than we expected to give back to the Commission. We're not expecting it. I'm expecting those to go down by the time we see lots of other buildings with different cultures and things. But even so, I think we're going to exceed what we saw before. And on its own, we were expecting to be able to reduce the electricity consumption of the whole European Union by about 1 to 2%, which is huge. If we get anywhere close to these savings being produced over the rest of the systems, we're looking at anywhere up to 4% of the reduction in electricity use of the European Union, just from looking at HVAC systems. So, I'm pretty certain we're going to be able to make the case to the Commission and legislators that this is worth doing, that there are savings to be had there. The issue now is political. What we have to do next is to establish benchmarks and show that those benchmarks are statistically robust, so we need enough data for that. We'll be producing benchmarks in a series of different areas. We're not really interested in the annual benchmark, energy use benchmark. It doesn't tell you much about what you can do, it just tells you where you are. We are much more interested in the sub-hourly benchmark. So we're going to try and come up with benchmarks which say, in February, at this time of day, if you have a pump, you should be expecting it to consume between this much and that much watts per square metre. So, and we're going to see whether we can do that. They're the diagnostic ones, they're the ones that allow you to make the savings. So here's examples of what that sort of looks like. So here's an Italian building, so this is the sort of data we've got. This is for the whole of February, so we've got lots of Mondays, Tuesdays, Wednesdays. You can see the time of the day during the week, and you can see the sort of watts per square metre. Because we connect the systems up to all the areas served, you actually get how much energy you're consuming by the floor area that's being served by the system. So very quickly we get to see, okay, this is all right, somebody's, for some reason, he was obviously running from Sunday through to Monday on a particular day. That's an anomaly, that's not how it's normally working. But from an ECO's point of view, from an energy conservation opportunity, you might well ask the question, why is the energy use in the middle of the day on a weekend lower than the energy use overnight on a weekend? So there is a control something going on which actually turns more stuff off during the day than it does overnight. Now, it could be perfectly reasonable, it could be there's a problem with the metering, there could be something to do with protection, who knows. But you start to see things that you can react to, and it's your building, and all of a sudden it makes sense for you to go and investigate. So, conclusions. Before the project began, the prediction was that we would achieve very worthwhile savings. The Commission wanted to see it, they wanted to demonstrate those to Member State legislators. At the moment we're far exceeding what we expected. That will come down, I'm certain, but I'm hoping that we will at least achieve what we originally expected. The unexpected thing is the confidence and the savings being released, which you can do with HVAC systems, because it's under the control of the owner of the building, not the occupiers. So because you have control of it, you can rapidly make savings, release some of that capital that you were spending on energy to invest further, and that seems to be what's happening in a lot of these buildings. If, when we finish the project in 8 months' time, we see those savings occurring elsewhere, we're seeing those sorts of reductions, I would expect there's a very strong chance that the European Commission, in the next recast of the Energy Performance of Buildings Directive, will require AMF unless there's a really good reason for not doing it. And I leave you with a question of if we can achieve those savings so cost effectively, why wouldn't you do it?